I especially wanted to thank Regina Zamora and Javier Sanchez and Craig Allen for inviting me, and Kuru for all of the organizational help that has happened. It's a pleasure to be here. And I don't know what that says either, but I'm going to talk to you about adaptations to climate change. And this will be a science-free talk. I'm not going to give you any graphs or any figures, but I'm going to talk to you. You've heard all morning about the kinds of changes that we're seeing in Spain and all over the world with respect to climate change. Many of you are in charge of managing natural resources in order to protect them. So this is a talk about what do you do? And that's what I and Craig Allen have been working on for the past couple of years, is taking the science that we know and trying to devise ways that resource managers can now employ that in order to protect their resources as best as possible. So there's a philosophy for adaptation, and this is going to be the theme of my talk all the way through. I've never sat through a talk in my life. I'm sorry, I have to stand up. Is this still good? You can hear me? Okay. Yeah. The philosophy is that the onset and the continuance of climate change over the next at least 100 years is going to require that we think differently about managing our natural resources. Climate isn't going to go from what we're comfortable with to something new and then be done. Climate is going to continue to change for the foreseeable future. So preparing for and adapting to climate change requires that we think differently about how we've managed our natural resources. And that makes it as much a cultural and an intellectual challenge as it does a scientific one. And here is a phrase that came from some of our managers in the Western United States, and I think it's prescient. They say, no action in the face of climate change is a decision that may carry the greatest risk. So keep that in mind as I talk my way through this. Now, there are three tenets, again, coming back to the main theme of this talk, that are going to change how we think about managing natural resources. One is that the climate patterns of the future will not be the climate patterns of the past. The second is that climate, of course, defines the environment, and it influences the future trajectories of the distributions of species and their habitats. So the climate is changing, therefore the habitat will be changing. And that means that specific management actions that we take to help protect our resources may only go so far. There may be so many great changes, as you heard this morning in some of the talks, that we may lose species or they may migrate out of our protected areas, and maybe our boundaries are not sufficient. So those are how we are framing our questions about how you manage for climate change. Now, climate change, again, you heard this in our talks this morning, climate change doesn't happen as just one more problem that you have to deal with as managers. It will occur in addition to all the problems that you now face as resource managers. Altered disturbance regimes such as fire or floods, habitat fragmentation or habitat loss, invasive species, air and water pollution, these are all occurring, and climate change will not only occur in addition, but it will occur on top of and make those problems worse. So it will alter our ability to manage each and every one of our current problems right now. So I'm going to be talking to you about mostly attending to the institutions, but I want to talk first, and this is a setup for Inigo's talk, who will come right after me. This is adapting to climate change and something about attending to the resources. And much of the science this morning was addressed toward how we take what we know and use it in order to manage better. So this is attending to the resources, and steps that we are advocating our U.S. natural resource managers take is you identify the resources and processes at risk from climate change. You identify the thresholds, and we heard about that this morning. You define the reference conditions of what is acceptable, what's perhaps not acceptable, and what you can do for restoration. And you develop monitoring and, importantly, assessment programs to use the long-term records you collect in order to manage better into the future. That's attending to the resources. Now, attending to the institutions is just as important, And I know at least in North America, they don't think about this very much. It's all about, let's get the best science and use it. And they don't do that very well either, I have to say. But attending to the institutions is almost as important. Remember I said it was a cultural and an intellectual challenge. So we need to implement management strategies for adaptation specifically. And that means diversifying the portfolio of management approaches. In at least the United States, in national parks that I'm most familiar with, they have a fixed set of protocols that they go through to manage resources. Many of those will not work in the future, so you have to add to those different methods for managing. We have to accelerate the speed at which science gets incorporated into management. That's accelerating that capacity for learning. We have to be able to assess and manage and plan at the right scales where the problems are, not just the political boundaries that surround perhaps our national parks or our wildlife refuges. You have to let the questions themselves define how and where you want to manage. Because someone mentioned this morning, species move across boundaries. Craig is going to mention it in a little bit. Fires move across boundaries. It's self-defeating to be looking only within political boundaries. So you let the issues define the right scales of time and space. That means developing partnerships with other organizations, because we can't do it all by ourselves. I mentioned already the other human problems that we've already caused, anthropogenic. You need to reduce those. That's probably the single most important insurance policy that will allow resilience of our natural ecosystems, is to reduce fragmentation, increase the corridors, reduce air and water pollution, those kinds of things. And then finally, but very important, you need to nurture the human capital, the people that actually manage these resources on the ground, and give them the power to actually make decisions that will help protect ecosystems. So I'm going to talk a lot about coming to terms with uncertainty, because that's what it's all about. We don't know what the future is going to be. Yes, we know it will be warmer. Yes, it will probably be drier. But how fast? How soon? How extreme? We don't know. So we're going to have to address that. And remember, back to my second slide, no action is the one that may carry the greatest risk. So it's not that we can just sit there and wait for something to happen. We need to start thinking about this now. And then we need to incorporate our climate change considerations into our day-to-day operations for management and into our day-to-day operations in national parks and preserves. So coming to terms with uncertainty, there are two kinds here. There's social uncertainty, and I'll talk about that first, and then there's scientific uncertainty. And this is a cartoon that says, one more study, and then I'll make a decision. No, I mean, I'm a scientist and I love to do research, but there is plenty of information now that will allow us to start taking action. So you don't want to wait for the final study, because then all our species will be gone and everything will be dandelions and cheatgrass. So we do not wait for the end of the science. But let me talk first with about the social capital and the social types of uncertainty. And I don't know, so I'm presuming about Spanish protected areas. But in the United States, very often resource managers have fixed protocols, and they see a problem and they go in and they say, okay, I will do this in order to manage it. And you either succeed or fail. And very often, failure is treated with punishment. People are fired from their jobs. That's not really the way it works, and it shouldn't work under climate change, because we're all learning as we go. So resource management advances only by bits and pieces, by incremental learning and gradual achievement of goals. And we need to incorporate that into the way that we treat our personnel when they fail in some aspects, or they only learn a little bit and you have to go back and learn some more. And that follows that there are gradients between success and failure, but you learn along the way. So every time we make a mistake because we didn't account for perhaps as extreme an event as occurred, we won't do that the next time. We're learning along the way. So, and we have to expect that even as we're learning, we're going to have failures. And again, that's not cause for punishment, which it has been in some cases in the United States. So you want to protect and reward those resource managers that are trying their best and learning as they go, so that you can carry that information forward. You don't fire them. And this is a joke that may fall flat, and I'm sorry. Cats are supposed to do their business in the box, but we are not. So never, never think outside the box. That's wrong. We have to be creative here because we don't know what the future will be. And that's the first thing about dealing with uncertainty, is you have to think outside the box. Okay, let me talk about scientific uncertainty. And I'm breaking this up into 3 different kinds, because this way it's not so paralyzing to say, we don't know what the future is going to be, I'll just wait and see. It's really much simpler than that. And the first kind I want to talk about is foreseeable changes. These are changes that we know are coming because we know the climate is warming. And these are changes that we might be in denial about. I don't want those glaciers to go away. The ones in Glacier National Park, I don't want them to go away. But they're going to. You know, sure as we can be, they're going to disappear. So now is a good time to start thinking about what you're going to do about your cold water fisheries, about your riparian areas, about your water supplies. Now is a very good time. Probably 10 years ago was a better time, but now is a good time because we're going to have to make changes. And there are some things you could do. You can restore riparian areas in order to enhance shading so that you keep cool water in the streams. You can perhaps restore flow regimes that have been stopped up by dams and diversions so that fish can go up and down. I mean, there are things that you could do to protect those ecosystems if you start now and not wait for these little glaciers to go away. Here's another example that I think is very wise. This came out of scientists that we work with at Scripps in California. And what they did is they looked across the country and they said, all right, where are there many areas in the United States already that have temperatures around freezing? And that's these orange and red areas here in the western United States mostly, and also in the east as well. And those are areas that have between 40 to 60 days a year where precipitation could fall as snow or precipitation could fall as rain. And those are ecosystems that are adapted to both rain and snow types of events. The rest of the western United States, it's not so easy to see on this graph, get mostly snow. But if you look forward into the future, and I'm taking you now 50 years into the future, all of those areas that are now orange and red will get 30 to 60 days per year less freezing temperatures. That means spring snowmelt will occur that much earlier. That means summer soils will dry out that much faster. It means there will be this much longer fire season than there used to be. We know this is going to happen. So now is a good time to start thinking about water supply, I've already said that, fire management, all of those things that come with having less snowpack and more rain events. Here, this is a slide from a paper that was already introduced this morning by Tony Westerling. We know, again, this is a certainty. It's an uncertainty because we don't want to believe it, but it's a certainty that we will see more large wildfires, we will see longer wildfire seasons, and this just isn't in the United States, this is all over the world. We're going to see increased spring and summer temperatures like I just showed you. It'll associate itself with more fires. We could start planning for this right now. We have to, otherwise we will see more loss of fire, catastrophic fire, affecting not only our forests, but habitations in forested areas. So planning is a good thing. Okay, so those are the types of foreseeable changes that we might think are uncertain, but they're really not. This is going to happen whether we like it or not. Then there are the imaginable changes. And this is an interesting category because these are events that may have occurred once or twice in our human past, and we have records that they occurred, but again, we're in denial that they will happen again in the future. So here is an example of a flood that occurred in the Pacific Northwest in 2006. And in November, it was something like 8 inches of rain on top of a cold snowpack, and it caused tremendous flooding. And it blew out roads and campgrounds. And you can see over here a huge blowout of erosion that occurred in response to that. The Park Service managers and the Forest Service managers in the western United States were caught completely by surprise. Should they have been? No, because this had occurred at least once or twice since 1950 before. But it occurred and managers forgot, and they didn't account for this kind of unexpected extreme event. Now, we also know that we'll see more extreme events in the future. Another example that I suspect Craig Allen will talk about is a sudden forest dieback that we saw in the southwestern United States just a few years ago. Killed off pinon pine for a very broad area of land. Managers were surprised. Should they have been? No. In the 1950s, the same kind of extreme heat events killed off ponderosa pine in the same zones. So these are areas that are unimaginable changes, but again, we're not thinking about them, so we're not planning to prepare in order to help our ecosystems adapt to climate change. Now, the third category is truly uncertain, and these are the unknown or surprising changes. And these are the ones you really can't prepare for because they're surprising. And the example that I use here is invasive species, and I suspect we'll see many more of those as our climate warms and we see unexpected novel types of ecosystems that come about because of species moving in. There is no way to plan for those except for making your ecosystems as robust as you can to change so that you can help maintain the resilience of the processes and the services that we value so much from our protected areas. There was a paper that came out last year, maybe 2 years ago now, in the journal Science, and it was about surprise, and it was a poll of a number of very senior ecologists all around the world, and they said, in the course of your career, have you become less, have you seen less and less surprise, have there been less times when you have been surprised by your results? And 75% of them said, no, we're continually surprised by ecology. The ecosystems that we deal with are so complex that we're probably always going to be hit with the unexpected. So again, the way to prepare for those types of unexpected changes or surprising changes is to make your ecosystems as resilient as you can to changes by reducing air and water pollution, by connecting your fragments so that species have a place to move, by reducing the unwanted invasive species, those kinds of disturbances you can manage in order to be better prepared for these kinds of surprises coming in. So there are certain kinds of management that at least in the US, resource managers do and are taught as a matter of routine. And those are the ones that occur on the bottom of this graph. Let's see if I can make this work. Yes. Okay, so here we have controllability, and you can control problems here in this axis, and these are the ones you can't control. And over here we have uncertainty, and it goes from low to high. And in the past, managers were taught that, you know, these are the problems that we deal with. You can control those kinds of problems. You have a cookbook type of recipe that says if you have such and such a problem, if you have too dense a forest, you go in and thin it. So these are controllable types of problems. These are the problems, and I'll give you examples in just a minute, where you can't control all the variables. So you try to make your ecosystems as robust as you possibly can. And that's hedging, or bet hedging, as it were. And then I'll talk about these in a minute. So what I'm doing is moving into a section now that is basically titled, What do you do? So this is increasing our portfolio of management approaches. Whoops, that's not supposed to happen? Okay. So there's optimal and control and hedging. Those are the two types on the bottom of the axis where you can actually go in and do something about problems. Examples, and they work best when uncertainty is low. Examples are fire management in the past or wildlife management. We have lost our top predators in many parts of the United States, so we have an overabundance of ungulates. These are elk. They actually go in and they cull them. They shoot them out. They call the problem solved, and they walk away until the next time the animals grow too abundant. And then they go and they shoot them out. That's controlling the problem. Over here, this is an example of, say you have a fishery, such as anadromous fish who go out to sea and come back, or trout that migrate in and out of your park boundaries. You can't control their lives when they're outside of the park boundary, but you can make it as easy for them to persist and survive and reproduce once they're inside your boundaries by making conditions as good as you can. So this example, for instance, is putting in large woody debris in your streams to give them shading, egg-laying habitat, food from benthic invertebrates. So that's a kind of hedging type of management technique. And those are the kinds of things that, at least in the US, resource managers use all the time. in order to manage their resources. There's one that's becoming more and more well-known, if not practiced, in the US, and I don't know if it's being practiced in Spain, which is the idea of adaptive management. And this is different than adaptation, although it's a part of adaptation. It's a very specific way of managing that treats your management as a scientific hypothesis. So it says, we don't know what the outcome will be of thinning this forest, but we're going to thin the forest and then we're going to monitor and see if it gives us something we want. So it accepts that we don't know, it accepts that there's uncertainty, and it emphasizes that you learn through management as you go, and you make mistakes, but you learn, and hopefully each time you make fewer mistakes. It's very successful when there's sufficient ecological resilience to make those mistakes. So you don't want to experiment with your last remaining population of an endangered species, because if you make the mistake, it's gone. So this is not for every situation, but it's a way of managing in some cases where there's still some resilience in your system so that you can try to figure out the best technique before it comes too late. Now, very important to the United States, it also is very important that there be institutional willingness to allow people to experiment. We often have a public that doesn't understand, and they want to see their national parks look a specific way. Well, it may not be that that's what they will look like under climate change. Perhaps the trees will go away and we'll have shrublands. Perhaps the trout will go away and we'll have bluegills. So you have to educate your public along with your resource managers as the resource managers do these experiments, so that they allow for this kind of uncertainty and they accept the idea that ecosystems change and that climate change is going to make them change even more, and you're doing the best you can. So that institutional willingness is very important, and it requires a lot of trust between the public, between different institutions. It requires a lot of cooperation. So you have to bring that along, and that's hard. Scientists like to talk to themselves. Managers like to talk to themselves. None of us like to talk to the public because they don't understand. We have to do that if we're going to increase the ability to manage our natural resources as well as we can. The last tool that I want to mention is scenario planning, or scenario-based planning. And once I tell you what this is, you're going to go, oh yeah, that makes perfect sense. But it's not commonly used in resource management. It's actually used very often in industry. And I'll give you an example. So scenario planning is basically saying, we don't know what the future is going to be, but we could think of 3 or 4 plausible futures, and it could be 1 or 2 of those. So we're going to plan for any one of those. And an example in the global business network that I use a lot is the past few years we had the jet fuel prices go sky high, and many airlines all over the world went bankrupt. There's an airline in the United States called Southwest Airlines, and they, 5 years before the price of fuel went very high, did a scenario planning exercise, and they said, gee, maybe the cost of oil is going to go high. Let's buy up a bunch of jet fuel and store it. And they did. So that while every other airline, at least in the United States, went into bankruptcy, Southwest Airlines was still able to offer $50 tickets because they had seen ahead and they were able to keep their airplanes full. And it was a scenario planning exercise that got them there. We want to transfer that to our ideas of resource management, because I think that we have lots of opportunity to be thinking ahead about what if. What if this happens? Would we be able to maintain our native fisheries or our forests or our beloved alpine plants? So scenario planning doesn't have to be a computer model, although it could. It could be you with a napkin at a cocktail party. And it incorporates the ideas of complexity. It incorporates outside influences such as economy and social types of factors, not just ecological or not just climatic. It assigns the probabilities. And again, this doesn't have to be precise. It can be, well, we think that it's likely that we'll have 30 years of drought. I mean, it's possible that we could. And if so, are we going to be prepared, or are we only going to plan for 2 years of drought? So you assign that kind of level of probability, and it forces you to consider those high risk, but is that right? Low probability but high risk scenarios that could happen, that could be catastrophic. And you might be able to manage to prevent catastrophe from happening if you only start at the beginning and plan for it from the beginning. So above all, these are stories. You're telling stories about what if, what could happen in the future. It does benefit from having all kinds of outside perceptions because we often think and speak within certain boundaries, and this brings in outside-the-box thinking, like that joke before. So scenario planning is going to be very useful for resource management in the future. And just as an example, the kinds of things that we do in the United States very commonly is we're here. We have a condition in our national parks. Say we have a certain type of population we want to protect. And we have a desired future. So we want a certain number of elk, and we want a certain number of bears, and we want a certain number of ptarmigan, different types of birds. So our desired future takes us down this path to give us that desired future. Well, here comes climate change. There's no way that we're going to probably get to that desired future. And instead, we might get to some undesired future, and we don't want that. Perhaps we'll see an extirpation or an extinction of all kinds of alpine species as they get squeezed off the tops of our mountains. So that's the way that we have been managing in the past. Instead, scenario planning says any one of these futures is possible. Any one of those futures is more desirable than that undesirable one there. So we're going to plan for any one of these kinds of contingencies going forward. And the kinds of things that you can do, and I don't read this, you don't want to read this, but it puts things on axes. At least this is one way that the Global Business Network has been thinking about it. It says, okay, we can divide the world into 4 quadrants. And in this case, this is high level. So it's saying climate change futures. We could have an enlightened public, and they have a broad understanding and heightened urgency for acting in order to mitigate greenhouse gases. The opposite down here is that nobody cares, and that we're on a trajectory of ever-increasing greenhouse gases and disaster. Over here, we have terrible management. We have nobody at the helm who's saying, we have a problem, we have to do something about it. The opposite side of that is that we have very high-level commitment, such as our new president of the United States, who's going to say, we have a problem, we need to do something. And within each one of these sectors, you make up stories. This one here is titled Riots and Revolution. Nobody cares, but we know there's a problem. We have big problems and big solutions. People understand, and we have senior management understanding that they need to do something. Is anyone out there? That's this kind of quadrant where we don't have anyone in charge and nobody really cares, etc. So you can devise these kinds of scenarios. You can also bring this down to a specific area. So this is one for Wind Cave National Park, which is a grassland in the United States. And here it's much more specific. It says, what's going to change that will affect our ecosystems the most? We have precipitation here. It's dry there. It's a very dry ecosystem. And they have grasses, and they have bison, and prairie dogs, and a cave. So if precipitation shifts so that you get more winter or summer precipitation, it's going to implement some effect on your ecosystem. On the other hand, you might have the same condition that we have today. So those are those 2 examples. And over here, we have drought severity here. It's either going to be really dry and we're going to get into some sort of shrubland away from grasslands, or it's going to just look like it does today and we'll still have our grasslands. So those kinds of scenarios can be useful in informing what you want to do in order to protect or prevent certain types of changes from happening. So I come back to this diagram. We have down here the kinds of things that we are comfortable doing as managers. We see a problem, we go in and we fix it. We see a problem, we can't fix it, but we can make conditions as easy as possible for species or ecosystems or services to persist. Where we don't have a lot of knowledge, we can partake of adaptive management and experiment our way into some kind of solution. And then we have scenario planning, which actually informs all of these types of opportunities and helps inform how we're going to manage in the future. So climate change is coming. We can't actually ignore it anymore. We're going to actually have to start planning and hopefully acting on it. And I come back to this philosophy that I started this topic with, which is that the onset and the continuance of climate change over the next century requires that we think differently about this problem. This is no longer, I'm just going to do the same old thing. And so it's as much of an intellectual challenge as it is what you do on the ground in order to protect it. And if I were going to summarize my talk completely, I would say you need to attend to the resources. You're going to hear more about that in just a minute from both Inigo and from Craig Allen. And then you would need to attend to the institutions. We need to let scientific knowledge guide management much more, at least in the United States, than it has before. We need to, very importantly, reduce the other anthropogenic problems that now affect our natural ecosystems. We need to broaden the management toolbox that we now use in order to address our problems, and let the issues, not the political boundaries, define how you manage. And that means you have to collaborate with your neighbors. Now, attending to the institutions means we need to diversify this portfolio, as I mentioned before. We need to learn faster between our scientists and our managers, and that goes both ways, because as managers practice adaptive management, we will learn from them what doesn't work. We need to, again, manage at multiple scales. We need to take care of our managers and make sure that they're allowed the freedom to make decisions which may be risky, because we don't know what the future will be. A lot of what I'm talking about is contained in a report that Craig and I worked on for the past couple of years, and this is its URL. It addresses different types of natural resources in the United States: wildlife, estuaries, marine preserves, forests, national parks. So this is a useful resource. It's 900 pages. I wouldn't wish it on anybody, but you can dip in and out of it. And with that, I will quit, and thank you very much.